Hello and welcome. So today we will be solving 2020 paper ECE, and what we are solving is the question from probability, right? And we have planned to solve from different branches, same as what we have done for the linear algebra, right? Let so 2019 I have already solved EC paper, and today we will look at this 2020. Okay, let's jump directly into the questions what we have here. So let's go from bottom to top. So we have this question number 55, and what we have been asked that if x is a random variable with uniform probability distribution function in the interval -2 to 10 for y is equals to 2x minus 6, the conditional probability is dash dash. So what we have to find is this conditional probability, right? And what we have given that x is a uniform probability density function, and we have given this interval for this x, right? So let's focus on this. First of all, the conditional expression that what we have given is this, right? We have to find the probability that y is less than 7 given x, random variable x, is greater than 5. So in this case, what you can do, first of all, you can make use of this relation, right? And you can write your complete probability in terms of x, right? It would be good, and it would be what for the further calculation it would be easy to see and easy to visualize, right? So with this given relation, what we can write this, so we can put here y, so y is 2x minus 6, so it would be less than equals to 7 given x is greater than 5, right? And we can further simplify it. So from here x is less than 6 plus 7 is 13 divided by 2, that is 6.5 given x is greater than 5, right? And we have given the PDF of this x, the probability density function of this x, right? So it is uniformly distributed from -2 to 10 here. So from -2 to 10, what would be the probability? It will be 1 divided by 12, right? So, and how we can, so if we have given two event A and B, so probability of A given B is equal to probability of A intersection B divided by probability of B, right? With the same analogy, here we can write this conditional event as probability that x is less than 6.5 intersection x is greater than 5 divided by probability that event B that x is greater than equals to 5, right? So if you look at this intersection term, what does it mean? That x is from greater than 6.5 and less than 6.5. So if you mark here, so maybe 6.5 will be somewhere here, and greater than 5, so greater than 5, so greater than 5 and less than 6.5. So this is the region that if you calculate the area of this region, you will get the probability of this event, right? So that, and if you look at this denominator term, then it is greater than 5. So we can also calculate this. So greater than 5, that means, so let me first of all calculate this numerator term. So the numerator term is going to be the area under PDF is 1 divided by 12 into 6.5 minus 5, that would be 1.5 divided by Now let's calculate this probability, right? So this is going to be greater than 5. So greater than 5 is this event, right? So it will be 1 divided by 12 into 10 minus 5 is 5. So this whole will be uh, 3 divided by 10, that is 0.3. So the correct answer for this is 0.300. Okay, now let's move to next question. So next question is, okay, now let's look at this question number 25. What we have been asked that two sides of fair coin are labeled as, so it is a fair coin and labeled as 0 and 1. The coin is tossed two times. How many times we are performing the experiment? Two times independently. So there is no relation between tossing the two coin, right? The let m and n denotes the label corresponding to the outcome. So m and n are the labels corresponding to the outcome of these tosses. For random variable x, so we have some random variable x and we have defined our random variable x like this, right? The expected value of this random variable x is, right? First of all, random variable, we say variable, but it is not a variable, right? It is it in actual uh, it has some function that takes input the samples and map it to some real number. So that is the another point, but let's solve this question. So so the what could be the possible value of this m and n? So we are performing two times toss, so m could be 0, n could be 0, m can be 0 1 and 1 0 and 1 1, right? And 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 this random variable is mean of m comma n, right? So this x is going to be mean of this and this and this and this. So 0 0, mean of this would be 0, mean of 1 comma 1 is 1, right? So random variable is going to take two value, that is 0 and 1, and 0 it will take with the probability 3 by 4 and 1 with 1 by 4. Now we will have to find the expected value of this x. So it will be 0 times 3 divided by 4 plus 1 times 1 divided by 4. So it will be 1 by 4, that is 0.25. So the correct answer for this is 0.25. Okay, now let's look at next question. So in question number 25, it is more oriented towards the communication, I can say, in electronics and communication. That question is from, I think, digital communication, but still let's look at this question. A binary random variable x takes value plus 2 and minus 2. The probability that x is equals to 2 is equals to alpha, then value of alpha for which the entropy x is maximum. So entropy, if so, okay, I should not discuss this question, but let me just give you an answer that, so entropy would be maximum when we will have more information, and we will have more information when we have more uncertainty, right? If we are certain about something, that means that event is associated with the less information, right? So the more the uncertainty, more the information, right? And if more the information, then we will have this more entropy, right? So entropy is maximum when information is maximum, and information would be maximum jump when probability will be half, right? Otherwise if we are saying that, so at the half information would be maximum, so that alpha value would be 0.5. So let's not worry about this question, you can escape it. Okay, now this question is again I think oriented more towards the communication, digital communication, but it's a good question, you can look at this. So what it is asking, that digital communication system transmits a block of n bits. So we have some block of n bits, right? So total number of bits are n, and the probability of error in decoding a bit is alpha. So what we are doing is that we are transmitting through some channel, and at the receiver side we are decoding this information, or you can say this bits at the receiver side. And in the question it is given that the uh, receiver will decode a certain bit, and let's say a certain bit with a probability of error, that is alpha, right? So receiver will decode a bit incorrectly with the probability of alpha. That is what we have given. The probability of error in decoding a bit is alpha. The error event of each bit is independent of the error event of the other bit. So decoding this bit and this bit are independent. So it has nothing to do with decoding this bit, right, to the other bits. The receive block is declared erroneous if at least one of its bit is decoded wrongly. So we will have here our bit, received bit, right? So there could be chances that one of bit may get decoded incorrectly. Then what we are saying, that the complete uh, block will be erroneous, right? That is what we have given. The received block is declared erroneous if at least one, if any one of bit have been got decoded incorrectly, then the complete we can say that this has the error decoded wrongly. The probability that received block is erroneous is, so we will have to find. So 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 let's suppose that we sent out the bit and we received all of these n bits correctly, right? If we are receiving all bits correctly, then if receiver is decoding all the bits correctly, that means we cannot declare this block of code as a erroneous, right? And if at least one of bit is getting decoded wrongly, or the probability of getting decode wrong is alpha, then other bit, let's suppose that one bit got wrong with the probability alpha, then other bit will be correct, right? So we will have this, or we can say, what we can say, that uh, that let's suppose that we received all of the bits correctly, right? So what would be the probability? 1 minus alpha to the power n minus 1, sorry, n, right? So this is the probability that we received all of the bits correctly. Then what we have been asked, that the probability that received block is erroneous is, so what would be the probability that if at least one bit is decoded wrongly, so if at least one bit, so this is the probability of receiving all the bits correctly, right? And if we are getting one bit incorrect, then it is erroneous. So we can say that the probability that that at least one bit got decoded wrongly will be 1 minus alpha to the power n. So this is the answer for this question. Okay, I think that was all question. That was the 4 question from this 2020. We will next time we will look at 2021 EC branch.